Welcome to the third tutorial for the GenoPred pipeline, an easy-to-use, scalable software pipeline developed at King's College London, which can be used to calculate polygenic scores. In the previous videos, we installed the GenoPred pipeline and then explained how the pipeline is configured. In this video, we will run the pipeline using some test data, following instructions on the GenoPred website, which is linked in the description below. The first step here is to download and decompress the test data. Before we run the pipeline, let's talk through some example configuration files to see what we're telling the pipeline to do. Looking at the config file, I can see we're specifying the example target, GWAS, and score list files for PT-clump and DBS-LMM polygenic scoring methods to be run, and it's in testing mode, where only chromosome 22 will be analysed. Let's now have a quick look at the target, GWAS, and score list files. In the target list, we're specifying one target dataset with the ID example plink1, with the path set to the test data we just downloaded, and the indiv report column set to true. In the GWAS list, we're specifying two sets of GWAS summary statistics that were in the test data. In the score list, we're specifying three score files, one that is stored locally with the path specified, and two that are to be downloaded directly from the polygenic score catalog. Okay, now we've checked our configuration, we can run the pipeline. We're going to run the pipeline specifying the rule called output all. This rule requests most components of the pipeline to be run, producing a report at the end to summarize the pipeline's outputs. It's often a good idea to perform a dry run of the pipeline using the n parameter, which simply prints out what it would do rather than actually running anything. This is a good way of checking that it will do what you expect before triggering loads of analyses. The dry run prints out a long list of steps that it will perform, indicating the inputs and outputs. Don't worry about understanding this output for the time being. I'll give an example of when it's useful to look through this later. Okay, so let's run the pipeline for real using the J1 parameter, telling it to run one step at a time. Once the pipeline is complete, it should say 100% complete, and you can always do another dry run to see whether there is anything else to do. Now let's take a look at some of the output to see what the pipeline did. As I briefly mentioned, this rule executes most parts of the pipeline, including quality control of the input data, ancestry inference, polygenic scoring, and report creation. A full list of the rules and what they do is provided on the website. Additionally, the website describes the structure of the output from the pipeline. In this case, the outdir in the config file was set to test_data/output/test1. Within that folder, the pipeline will have created a folder for each target dataset, and there you can find several outputs of interest. For example, the sample level report can be found in the reports folder. You can open this in your browser to see a summary of the quality control and polygenic scoring outputs. Also, check out the website for more information on where outputs are stored and look around the test data output to see what you can find. Finally, while using the test data, I want to demonstrate how you can modify the configuration of your pipeline once it has already been run. This is quite a common situation. For example, you might run the pipeline with one GWAS to start, but then you want to run it for 20 more GWASs. This is easy and efficient to do with GenoPred, as you just modify the configuration file and it will run the steps required to generate the requested outputs without the need to rerun steps that are unaffected by the changes in the configuration. As an example, let's add a new GWAS to the GWAS list. I'll just use the coad01 sumstats again, but give it a new ID so GenoPred thinks it's a new GWAS. Then, if we do a dry run, we can see that it would run some more steps. we can look at the dry run output to check it is doing what we expect. The output we see is expected. The new GWAS will need to undergo summary stat quality control, and then downstream processing using polygenic scoring methods. Then target sample scoring, and finally the sample and individual level reports will be generated using the sample report and indiv report rules. Then to run the pipeline, we can just remove the n parameter and specify the j parameter. So that is the demo of using the test data, and you're now in a good position to try running the pipeline with your own data. Check out our website and videos to get more information on requesting and finding other outputs from the pipeline and running the pipeline in parallel on high performance and computing clusters.